discussing about the momentum. And for momentum, you must be knowing that the formula for force, that is F is equals to dp by dt, that is the rate of change of momentum is force. From here we got two formulas, that is from P is momentum, just replace the P with mv. So there will be two formulas from here. So first case will be like when the mass is constant. So when mass is constant, the formula will be F equals to m dv by dt, and when the velocity will be constant, and you can write here like v is variable and here m is variable. So at this time you will get a formula that is v dm by dt. So this formula further becomes ma. So force equals to ma. This is a very popular formula that we all know. So basically this formula is m dv by dt plus v dm by dt. So with the chain rule of differentiation, this formula becomes this, and then it comes to this, because when mass will be constant, this will be 0, and when velocity will be constant, so this will be 0. For one item will be 0 in each of them, and we would be left with only one vector. So these are the two formulas for that. After that, there is very important concept of impulse. We have already discussed this in the last videos, but it is very important to understand in the momentum, so we are doing it again. So here the dp is equals to f dot t, and this becomes impulse, and the SI unit for it is Newton second. And sometimes there will be questions regarding this. F and T graph will be given to you. Area under the graph will be this, because F and T will be multiplied here. So now, first topic into the momentum. This was the general discussion for the momentum, and now we would be moving for the next part, that is conservation of linear momentum. Conservation of linear momentum. So in this topic, basically, there would be two objects. They are moving like this. They got contacted, and then they start moving again. So like this is u1, this is u2. Here the velocity gets changed. So in this type of contact, first of all, there will be like collision. We will say that it will be elastic collision. So in elastic collision, momentum is conserved and energy is also conserved. So both of the things are conserved in elastic collision. So here we will have two formulas for that. That would be like the initial momentum, like this, if this body is m1 and this is m2, so obviously this is m1 and this is m2. So m1 u1 plus m2 u2 will be equals to m1 v1 plus m2 v2. And the kinetic energy of both of them, like half m v u1 square plus half m u2 square, will be same with this, plus half m2 v2 square. So these two formulas will be valid for them, because it will be an elastic collision. After that, there is another collision. That type of collision is called inelastic collision. Inelastic collision. So there will be categories of inelastic collision, perfectly inelastic collision, or super elastic collision, total inelastic collision. So basically, inelastic collision is, see, momentum will be always conserved. Momentum is conserved, but energy is not conserved. So these types of collisions where the energy is not conserved is called inelastic collision. So what happened to that energy? Why the energy is not getting conserved? Basically, when they get collided with each other, there may be some sound, there may be some light. So basically, the energy got wasted here because we know that energy can never be created nor be destroyed. So how we can say that energy is not conserved? See, energy is conserved in total way, but energy is wasted in light and sound or something. So energy got wasted here, and the further part, that is V1 and V2, they are not getting the total energy from this. So if this total energy is 10 joules, here they are getting 9 joules. So 1 joules is getting wasted in other activities. So in these types of questions, when we will discuss inelastic collision, see, when we will have inelastic collision, the figure will be same. That is U1, U2, V1, V2, and M1, M2. Here also M1, M2. The equation for momentum will be same, but we can't use the equation of energy. So there is another thing, that is E. That is coefficient of restitution. I'll write here coefficient of restitution. So this E value is V2 minus V1 upon U1 minus U2, means the relative velocity of recession. Like if I am sitting here, I am seeing that how much faster this body is moving away. And if I am here, I am seeing this body, how faster this body is coming to me, because then only it will collide. Suppose if this is moving with 10, this is moving with 7. So it will, the person here will think that this body is coming towards with 3. And if this is moving with 7 and this moving with 10, so this person here or here, this person will see that this body is moving away from by 3, and this person will think that this body is going farther away by 3 or negative 3. So this is the relative velocity between them, relative velocity between the final bodies divided by the relative velocity between them for the initial one. So we call it as relative velocity of recession and divided by the relative velocity of approach. So this we use instead because we don't have the energy formula here. We can't conserve the energy equation. So in this type of formulas or this topic, inelastic collision, in this type of collisions, we have to use this. That's it. There is nothing much in this topic as per AP Physics is concerned. And there is next topic there is given in your book, that is center of mass. So in this topic there is just a one formula, that whenever suppose the mass is discrete and we have to the summation of the values, suppose xi into mi divided by total mass. So the center of mass can be calculated with this. Like for the bodies, the center of mass is in the center. For symmetrical body, it is very clear that it is at the center. So center of the mass is the mass where it is a point where we can say that all of the mass is concentrated over there. Like if we put some finger, like if this is a pen, if I say that I am able to balance it somewhere at the center or in between, so that point is center of mass, and this formula is given in your book, and this is the on last topic for momentum. So hope this video would be helpful for you, and I have covered most of the topics of momentum that are given in your book. So hope you would understand momentum now better. If you still have some doubt, just put it into the comment section.